So fundamentally, first we would just want to cover the basics of, what is a matrix, right? And the things that you need to know about them. So the first thing you want to recognize is the size of matrices, right? Or you can use dimension if you want. Personally, I don't like using the word dimension, but in case they mention that word, you'll know what that means. So a matrix A, that is, 1, 2, 3, 4, 5, 6, would have 2 rows and 3 columns. And so that is the dimension of the matrix. We would say that this is 2 by 3, right? The number of rows by the number of columns, right? Rows by column. And this is important because when we're doing addition and multiplication, that is one of the first things that we have to be able to understand, because addition requires them to be the same, whereas multiplication requires the two numbers on the inside to be the same, right? So that's the first thing you want to recognize, right? So if I have a matrix like this, and if you want to practice in chat with me, just to be engaged, even so we're practicing, what is the size of this matrix, right? And it's okay to be wrong right now. Better to be wrong now than on the exam, right? And you actually remember things more if you get it wrong. So what is the dimension of this matrix, or the size? Well, I count how many rows there are, 1, and then I count how many columns there are, 1, 2, 3, 4, 5. So it's a 1 by 5, right? Or let's do another one where I have 1, 2, 3, 4, right? What's the size of this matrix or dimension? Well, this has 4 rows and 1 column, right? So that's the first thing we have to understand, is what is the size of a matrix? Because once you understand that, then you can actually start applying operation, right? And so the next thing we'd want to talk about, let me actually insert a blank slide. I'm just going to jump straight into the transpose before I do addition and subtraction and multiplication and all that. So the transpose of a matrix, okay, A transpose, is equal to the columns and rows being swapped, right? So just to give you an example, A is equal to 1, 2, 3, 4, 5, 6, right? Then A transpose is equal to row number 1 becomes column number 1. So 1, 2, 3, and then 4, 5, 6, like that. And I'll use some color coordination here, just a little bit. Now, one thing that's important, because this is a potential question that I could ask you, is what happens to the dimensions? Well, this used to be 2 rows, 3 columns. Now it's 3 rows, 2 columns, right? So the transpose flips the dimension. Does that make sense? Now, if you're wondering, well, what if it's a square matrix? Well, then it's still the same number. It's still a square, right? So if A were equal to 1, 4, 7, 0, negative 1, 2, 3, 8, 9, then A transpose is still going to be a square, a 3 by 3. But now it's 1, 4, 7, 0, negative 1, 2, 3, 8. Oops, that's not an 8, that's a 9. 8, 9. Does everyone see that? This becomes this. Gotta use some colors here. This becomes this. Now, if you're wondering, could I do it where I change the column into a row? Like I do 103 column becomes 103 row? Absolutely. But I think in my experience, most people can do rows to column more intuitively. Like they can do that mentally versus doing columns to rows. But that's just my experience, right? Any questions on that idea, right? Transpose. So the next thing was addition, right? What if I want to add two matrices? Well, in order to, and I guess subtraction by default, in order to add or subtract two matrices, they must be the exact same size, okay? So if one is square, the other one has to be the exact same square size, right? So if I had a 3x2 plus a 3x2, then their answer would also be a 3x2, okay? The size does not change. Now, if I had something like a 3x3 plus a 4x4, the answer would be D and E because the dimensions do not match, right? Does everyone see here? Not the same. Yeah. That's the whole point. In order to add two matrices. Same thing with subtraction. I mean, again, you could just put plus or minus and it's the same thing. And that's the nice thing about addition and subtraction. It behaves the exact same way. Okay. Are there any questions on that? So then the question is, okay, I understand the rule of addition. So how do I add two matrices? Well, let's just do an example. 1, 2, 3, 4, 5, 6 plus 0, -1, 2, 4, -8, -3. Okay. So first thing I do is I check the sizes. Okay. And I say good, good. So check, check. So everything is good to go. Then when I add them together, I just add them component wise. So 1 plus 0, 2 plus -3, 3 plus 2, 4 plus 4, 5 plus -8, and then 6 plus -3. And then if you add this correctly, you get 1, -1, 5, 8, -3, -3. Now, if I make a mistake for those in here, just interrupt me and say, hey, I think that should be a different number. Perfectly fine with me, okay? Any questions? So that's the basic principle of addition. Subtraction, you just do subtraction, right? So nothing too wild about that. It behaves the way you expect it to behave, which is always nice, okay? And so the next thing we can talk about is scalar multiplication. And so what I mean by that is I multiply a matrix by a number, not a matrix times a matrix, but rather a matrix by a number. So something like, I'll just do a straight example. If I do 5 times A, which is equal to 5 times, and let's just make this up, 1, 2, 3, 4. This right here is A. So I'm just going to say that this is made up. Then this would be equal to 5 times, sorry, wrong order, not that it matters, 1 times 5, 2 times 5. It doesn't matter what side you put it on, which is nice. And then 4 times 5. And this is equal to 5, 10, 15, 20. Now, if you're wondering how much work do you have to show, it depends on the problem. But, I'll say in the direction, show all work, or I'll say calculator's okay, just to make it easy. So you don't even have to think about it. I'll tell you on the exam, how much work I want you to show, okay? Any questions? So now we know addition, subtraction, right? We know scalar multiplication. And so the last thing that we need to know is matrix multiplication. So now we can do matrix multiplication. Matrix multiplication. All right. So in order, actually, you know what? Just to make it very clear, because I'm kind of doing both of them now. 5.1, 5.2, matrix algebra. Okay. I'm just doing all of it together because 5.1 stops at transpose in this one, but I'm just going to do it all together. In order to multiply two matrices, A and B, the columns of A must be equal to the rows of B. Now in English, that sounds kind of confusing. So if A is M by R and B is Q by N, then A times B, sorry, let me do it this way. A times B is defined when R is equal to Q, okay? The result is a matrix that is M by N. So just to show you an example, A, M by R, times B, R by N, is equal to A times B, M by N, them being multiplied together. And let me give you a quick second, and I'm actually just going to pause the video for it. All right. So just to make it more obvious, we'll do some examples with numbers. So if A is 2 by 3 and B is 3 by 7, what is their product? Dimension. So 2 by 3 times 3 by 7, right? So you ask yourself, okay, do these match? Yes. Or you can do like a little check mark. Check. And so this is going to be equal to 2 by 7, right? The two outside numbers. Like that. Okay? And you just got to keep track of that. Now, if they don't match, so if A is 2 by 2 and B is, 1 by 2, then 2 times 2 times 1 by 2, these right here, no. So then this is D and E. Okay? Or I mean, if you want to say, you could say like match. No match. Right? That's the idea. So we get the basic principles of dimension. Now, what we have to do is apply the rule. So how do we actually multiply? Well, let's just learn by example. So find the product of A equals 1, 2, 3, 4. And B is equal to 4, sorry, not 4, 5, 6, 7, 8. All right, I want to multiply these together. And so the way we do it, A times B is equal to 1, 2, 3, 4, 5, 6, 7, 8. Okay. We use what is called the dot product. Okay. Now I wish I could color coordinate this perfectly, but I really can't. Okay. So what you're going to do is you're going to take this row and this column, and you're going to take the dot product. And we learned that that is defined as 1 times 5 plus 2 times 7. This times this plus this times this. That's what you're doing. Okay. You're multiplying those together. Then, okay, maybe I could actually do this. Let's see if this works. I want to make sure it looks natural. This times this will be equal to the first row, second column. So 1 times 6 plus 2 times 8. So I can draw this right here, and then I can draw this right here. Okay. And then I'll use a different color. I don't know. Let's use aqua. And so now the second row, first column. Oh yeah, see, now this is where it looks a little different. So let's use a different color, like, I don't know, purple. So this one times this one is going to be 3 times 5 plus 4 times 7. Draw a little circle around it like that. And then this one I can actually change it in. So 3 and 4, and then 6 and 8. So 3 times 6 plus 4 times 8. Hopefully that's not too confusing. And I have multiplied them together. Okay. Now, as I've mentioned before many times, you have to be able to do anything by hand for 2 by 2. Okay, so that is a definite must. And so this is going to be equal to 5 plus 14. Okay, is there a question there? I just want to make sure. All right, and then 6 plus 16, 15 plus 28, 18 plus 32. And then I get 19, 22, 43, and 50. Okay. And that's how you multiply 2 matrices. And if you can do that one, then you can pretty much do all of them because they all follow the same pattern, right? So now what we can do is we can just practice, doing a couple questions from, say, the review. Because now we've defined all of the operations, and I just want to verify that I have defined all the operations. I believe I have. But are there any questions before we just do a couple more examples in relationship to operations? Yep, looks like we're good to go. Now, you do want to mention this, and I will mention this. Order matters because A times B does not equal B times A, usually. Okay, so you have to be careful when doing a problem. Okay, so let me go to the review. And so here is the first problem. I'm not going to do all of them. I will just do maybe like 2 or 3 of them. But let's go here, new slide. And so this is from the review. So I'll do the first one for sure. So A says 2 times A transpose plus 3B. Okay. So you still want to follow like order of operations and all that. So first, find A transpose. So A transpose is equal to, well, this becomes -2, 0, -1, 2, -1, -1, because I basically made all the rows columns. And yeah. So 2 times -2, -1, -1, 0, 2, -1, plus 3 times -1, 1, 1, -1, 0, x. So this is 3 by 2, sorry, backwards, 2 by 3, and this is 2 by 3. So this and this are good to go. They are the same size. If they were different, I could just say not possible because you wouldn't be able to add them together. So then I distribute the 2 inside and the 3 inside. So then I get -6, but that's not correct, it's -4, -2, -2, 0, 4, -2, plus -3, 3, 3, -1, 0, 3x. And then from there, I would combine them together. And this would be equal to -7, 1, 1, -1, 4, and then 3x minus 2. And that's my answer, right? Are there any questions on that one? I'm going to do b squared just because we have never seen a square, but I just want you to see what it looks like, right? Well, no, I think I have mentioned it in class, but we'll just go over that one. Any questions? All right, I'm going to copy this over just so I don't have to keep looking back and forth. So we will do f, which says b squared. So b squared is just equal to b times b. You just multiply them together. Okay, you just multiply them. So then this is equal to -1, 1, 1, -1, 0, x times -1, 1, 1, -1, 0, x. This is 2 by 3. This is 2 by 3. Do the inner numbers match each other? Do these two numbers match? No match. So the answer is not possible. And that's it. Okay. Any questions on that one? I just want to make sure. You know what? I'll do, let's see, 2 by 3. I'll do B. Sorry, not B, D. I'll do D. Like I'm not gonna do every single one of them. Unless there's a specific one that you want to see for those who are here. Unless there's a specific one you want me to do, I'm gonna do D and then I'm gonna move on. So B times A. So this is gonna be equal to -1, 1, 1, -1, 0, x, and then -2, in this case, 0, -1, 2, -1, -1, like that. Okay. So from there, I check the sizes. So 2 by 3, 3 by 2, check, check. The inner numbers match each other, which is exactly what we want. So does everyone see that? That's what we want. So now we can say, okay, this is going to be equal to a 2 by 2. So this number and this number are going to make my final answer. Now I would give yourself a lot of space, okay? But it's going to be a 2 by 2. In fact, I'm not even going to write it down. I'm just going to leave it open because trust me, you might run out of space before you know it. So any questions though? I just want to make sure. Okay. So I'm going to take this one times this one to get the top left. So -1 times -2 plus 1 times -1 plus 1 times -1. That's my top left corner. Okay. Then, like I said, I didn't even give myself enough space here because I'm going to run out. So let me move this over. Ah, I mean to click there. There we go. And then for the next one, I'm going to do this one and this one. So -1 times 0. And if you can do this part mentally in your head, I would highly recommend it. Just, obviously be careful because very prone to errors if you try to do it all in your head. So there we go. And then the next one would be this one times this one. So -1 times -2 plus 0 times -1 plus x times -1. And then let me erase that. And then it would be this one times this one. So -1 times 0 plus 0 times 2 plus x times -1, like that. Any questions on that? I just want to make sure. Yeah, so actually, that's a great question. So someone asked, this type of problem is okay to solve with the calculator. If they were all numbers, yes. But do you notice that that letter X is right there? So you wouldn't be able to do this in your calculator because your calculator doesn't accept non-letters. Does that make sense? So you would actually be forced to do this one by hand. But if they were all numbers, then yeah, absolutely. You could just use your calculator and be on your way. Any other questions? So then you got to do all this math. And so it's going to be 2 plus -1 plus -1, which is 0. This is going to be 0 plus 2 plus -1, so 1. 2 plus 0 minus x, so 2 minus x. And then 0 plus 0 minus x is a negative x. And I believe the solutions are in this. Let me just double check. Any questions on that? 0, 1, 2 minus x negative. We got that. So that's how you do matrix multiplication. If you can do that one, you're on your way, right? You're good to go. All right. So I believe that really covers 5.1 and 5.2, just being able to, manipulate them and multiply them together, right? And I'm just looking through the homework for any other conceptual question. If you have to distribute, so just a reminder, distribution. So in the event that you have to distribute, A times B plus C is equal to A times B plus A times C. So you have to distribute on the left-hand side. And if you distribute on the right-hand side, then you would be on the other side, right? So the order does matter. We have mentioned that before. Order does matter. Okay. Any questions on that? All right. And I think we can move on to the next section, which is 5.3/4.2. 4.2. So 4.2, I don't know why they named it this way, and that was Gauss-Jordan elimination. Okay. So Gauss-Jordan elimination. So for this one, right, the big thing is you just need to understand how to solve basic systems, okay? So that's using row reduction, right? And I said in class, you have to be able to do 2 by 2 by hand. And then for anything else, if you can properly set up the matrix, then you can use it on your calculator. And speaking of calculator, let's go back and just remind ourselves on how to enter in matrices, right? So I'll bring this down here for us. Here we go. So if I want to make a matrix, we go to second x squared, which takes us into the matrix mode. If I hit the right arrow key, I go to where all the operations are. So the first one is determinant. The second one is T. This stands for dimension. I've never used that one. We can try it out. And then after that, the next one that we're interested in is RRES. Okay. Everything else, not useful to us. And then this edit button is where we actually create that matrix, right? So that's where we want to go if we want to type in a matrix, right? So let's say that I wanted to type in a 2x2. So 2 rows, 2 columns, and I do 1, 2, 3, 4. Okay. Second quit to leave, second matrix, and then I want another one. So I go to B, and I make this a 2x2, and I make this 4, 5, 6, 7. Okay. So then I do second quit, second matrix. So if I want to find the determinant, I use this one. If I want to find the transpose, I do this one. Now you have to first use the matrix. Let's see what dimension does, or dim. So second matrix A, and it says 2 rows, 2 columns. There you go. So that's what it does. It tells you how many rows and columns there are, which is pretty useful, I guess. If you want to pick a matrix, you go to second matrix and you just press enter for whatever matrix you want. So I want A, and then if I want to take the transpose, second matrix math, transpose. If it's a multiple choice question, you don't have to show work to me. So you can just use this if you're able to. Okay. Now, if your calculator is capable of solving these problems using letters, then that calculator is not allowed to be used, because that just goes against the policy of the course. So make sure that your calculator is in line with all of the restrictions. Okay. And then we'll talk about row reduction. And then if you do want to take the inverse of a matrix, which we'll talk about in a minute, you do matrix A, and then you hit the inverse button, which is x to the -1. Now, if it doesn't have one, it'll say does not have one. Okay. And if it does, then it will show you the inverse solution. Okay. Are there any questions on that? Okay. 1 sec. All right. So let's just keep going. So again, Gauss-Jordan is all about solving a system using row operations. So we're just going to practice by example. Okay. So example, solve 2x plus 3y equals 1, and then 5x plus 4y equals 6. Okay. Now, do keep in mind, if you're doing a problem like this, I could make it a word problem, and you would just basically, it's not new, because we learned how to solve these word problems back in the past. But rather, now we're just setting it up as a system and solving it in a different way. So step 1 is set up augmented matrix. So you want to augment the matrix first. And as I said earlier, you always want to write it like this. So 2, 3, 5, 4. The equal sign is a vertical line, and then this is 1 and 6, right? And so we learned 3 row operations: row swapping, addition, and scaling. So step 2 is to row reduce. So as I've told you in class, the thing that you want to eliminate is this number and then this number. You want to make those 0. So the question is, how do I do that? Well, I'm just rewriting the matrix. If you were doing elimination method, you would multiply one row by something and maybe another row by something and then add them together. So I would multiply row 1 by -5 and add it to 2 times row 2, and that's going to be equal to my new row 2. Okay. So this is going to be since I'm not changing my first row, like that's not the one that I'm actually trying to change, I write it like this. And in fact, I'm actually going to move it up here so that it can flow a little bit better. We'll put it right here. Right? So, I mean, off to the side, it's -10, -15, -5, 10, 8, 12. And so if I add those together, I get 0, -7, and 7. So 0, -7, and 7. Okay. And so your goal is to make it the identity matrix. So you want a 1, 0, 0, 1. So what I would do next is I would take row number 2 and multiply it by -1/7 or divide it by -7. I mean, you can write it either way. It's the same thing. As a personal preference, I always write it as multiplication, but whatever makes you happy. And so we're not changing row 1, so we leave it alone. But row 2 is going to become 0, 1, -1. Okay. And the key to doing well with this is you got to remember what everything is. Remember, this is the X column. This is the Y column, right? So that is what those numbers, or sorry, those columns represent. So then now I want to eliminate this 3. So what would I do? I would take row 2, multiply it by -3, add it to row 1, and that's going to give me my new row 1. Okay. Are there any questions on that so far? Just want to make sure. All right, no questions so far. So the second row, I'm not doing anything to that anymore. But now I'm going to do 0 plus 2 is 2, -3, right? Plus 3 is 0. So I'll show the work off to the side. So it's 2, 3, 1, 0, -3, and +3. And so this is going to be 2. Because when I add these together, I get 2, 0, 2. And then from there, let's put this in a little box. We're going to multiply the top row by 1/2. And we're going to get 1, 0, 1, 0, 1, -1. And so what this tells us is our answer is x equals 1, y equals -1. Right? Does everyone see that? Now, if you did this on your calculator, that's how you would do it. Now, on an exam, if I say do it by hand, you will not get all full credit if you do it with the calculator. So you go to second matrix, go to your A matrix, press edit. Now I'm going to make it a 1 by 1, and then I'm going to put 0 in here because what that does is when I make my matrix, it'll actually make it correct. It'll empty it out. So 2 rows, 3 columns. They're not going to draw the line for you. You just have to visually see it there in your brain. So our original was 2, 3, 1, 5, 4, and 6. Then you quit. You go to second matrix. You go to math. Go all the way down to RREF, second matrix, the first one, and look at that. Oh, guess I made a mistake. Let's see. Oh, I see what I did. Wait. Looks like I made a sign error somewhere. Hold on one sec. I gotta figure out where I made the sign error because they got it. I got the -1, but it looks like I made a small sign error somewhere. So let me look real quick. So I found the mistake. This 2 and this 2 should actually be 4. So let me erase that. So 4, 4, and then this simplifies to 2. So as you can see, checking my answer with the calculator resulted in me catching a mistake. Okay, does everyone see that? So that's my answer. And so the solution, I mean, you could write it as 2, -1. I will tell you on the exam how I would want you to write it, usually as an ordered pair. and it's in the direction, right? Are there any questions on that? Just want to make sure. So if you're solving a problem and you get something with, if you get something that results in the matrix not being a solution, so no solution would look something like this. You're going to have a matrix, you might have like 1, 0, 3, and then I don't know, 5, 0, 1, 0, 2. Let's just make it 0 here. And then 0, 0, 0, 4. Okay. So this is saying, equation number 3 is saying 0 equals 4, which is not true. So when you get 0 equals a number, then it's not a solution. Okay. Now, the next example that I want to cover is the infinite solution. Okay. So not only do you have to be able to solve for the row reduced echelon form, right? So this right here is called RREF. You also have to be able to solve a problem if I give you RREF. So you have to be able to take an RREF problem and finish it. And sometimes some students get tripped up by that because they're so used to doing it themselves that if I do it for you, it throws you off, right? So let's do an example like that. So given the RREF is, and I'll do one from the review, 1, 1, 2, 0, 0, 0. Now they were not nice enough to draw you the line, but I will draw it for you. Find the solution. Okay. And you know what? I'm just going to go to another slide because I'd rather be any more space. All right. So step 1, write equation. Okay. So you want to write them as equations. So x plus y equals 2, like that. Step 2, solve for y. So x plus y equals 2, y equals 2 minus x. Step 3, plug into x comma y. So x comma y is going to be equal to x comma 2 minus x, like that. Are there any questions on that? This problem is, it's actually like, it's so easy, I guess you could say, that it makes it difficult. Some students actually struggle with this because too much of the work has been done for you, and that's what really throws you off, right? And so you just have to remember that. Okay. I'll do one more from the review. Okay. Solve the system if, wrong if, the, my handwriting is terrible right now. Row reduced echelon form is 1, 0, 0, 0, 1, 0, 0, 0, 1, 3, 2, 0. Okay. So this is the best case scenario because this is when it's unique, right? This is x, this is y, this is z. So x equals 3, y equals 2, z equals 0. So the answer is 3, 2, 0. And that's it, right? Any questions on that one? All right. So now we can talk about matrix inverses. So 5.3 slash 3.6, which is matrix inverse slash determinant. Okay. So the determinant of A for 2 by 2 is, so this is how you find the determinant. You take a matrix. And this only works for 2 by 2. And you only have to know for 2 by 2. Okay. A times D minus B times C, right? A times D minus B times C. Doesn't matter the order you do it in, like C, B, B, C, D, A, D, it's all the same. Okay. If the determinant of A does not equal 0, A inverse exists. If determinant of A does equal 0, A inverse does not exist. Could be an E. Okay. Because the formula for the inverse of a 2 by 2, let's just do an example first. Find the determinant of 1, 2, negative 3, 4. Okay. So this is equal to 1 times 4 minus negative 3 times 2. Please be careful with your negative signs. So 4 plus 6, which is 10. Okay. Does everyone see that? Any questions on that? All right. And so the inverse of 2 by 2 is the following. So if A is equal to A, B, C, D, then A inverse is equal to D, A. So I do a swap, and then negative B, negative C. Sorry, I forgot the other part of it. And then you got to multiply that by 1 over AD minus BC, which is just 1 over the determinant of A. I guess I should mention that too, because that is something that is used. The other notation that we can use is the absolute value, because we do use that notation in class. I want to make sure that we're all comfortable with it. Any questions? I want to make sure. All right. So, given A is equal to 5, negative 2, 10, and negative X, let's put it up here, it would fit. For what values of X does A have an inverse? Okay. Actually, I'm gonna go to the next slide because I want more space. So next slide. So step 1 is find determinant of A, because that's going to be the part that goes on the outside right there. So the determinant of A is equal to 5 times negative X minus 10 times negative 2, which is going to be negative 5X plus 20. Okay. Step 2, find A inverse. Okay. So A inverse is equal to 1 over negative 5x plus 20. And then I'm going to swap the 5 and the negative x. So those are swapped. And then this becomes positive 2. This becomes negative 10. Okay. And so the only issue that's going to happen is this right here. Okay. This cannot be equal to 0. So negative 5x plus 10, wrong number, 20 cannot be equal to 0. So then negative 5x cannot be equal to negative 20. So x cannot be equal to 4. So all values except x equals 4 make an inverse. Because if I plug in negative 4, I would get division by 0. Does everyone see how I did that? I just want to make sure. Any questions on that? So that is determinant, that is inverse, right? Now, what you can do with the inverse equation, okay, is the following. So, for a system of the form ax plus by equals c, and dx plus ey equals f, we can write it in matrix form. Ax equals b, which is a, b, d, e times xy, which is equal to cf. Okay. Actually, I'm going to do this instead to make it a little bit more consistent. A, B, C, D, E, and F, like that. So if, and so this is A, X, and B. If A inverse exists, the solution would be equal to A inverse times B. So you can solve a system using the inverse. Okay. So I want to practice doing that for one problem, and we will do that together. Okay. But are there any questions before we move on? So if I want to solve for a matrix, I just multiply. So the reason we do that is, ax equals b. If I multiply both sides by the inverse, and because I do it on the left side on the right, sorry, on the left side on the left, I also have to do it on the left side for both. These cancel each other out, and I get x equals A inverse times b. That's why. Okay. And that actually answers question number 12 on the free response. All right, so let's go here. So we're actually going to do C. I want to do C together. So let's do this one. So step 1 is to augment. Sorry, not augment. Find A x equals b. So remember, when you're setting up a matrix, the first column is x, the second column is y, the third column is z. So negative 1, 1, 0, 0, 1, negative 1, 1, 0, 1, right? You're not augmenting it, although you could do it with augmentation. The purpose of this problem is not to augment because we want to use a different step. Although personally and theoretically, this technique is more inefficient because matrices, in calculating the inverse matrix, is actually very time consuming versus say row reduction. So that's why we don't actually have to use it. The X column will always just be X, Y, Z, your variables. And then B are the numbers on the outside, -1, 6, -1, like that. And then step 2 is to compute X equals A inverse times B. So this is we're actually going to use our calculator. So grab your calculator for those watching. And you're going to go to second matrix, and you're going to go to edit. And then you're going to make a 1 by 1, put a 0 in there, and then now make a 3 by 3. So not an augmented matrix, just a 3 by 3. And then type in your numbers, -1, 1, 0, 1, -1. Sorry, I messed up, didn't I? I did. That should be 0, 1, -1. And then this is 1, 0, 1. I want that. And there we go. That's the first matrix. Then you do second quit, second matrix, edit, and then you're going to make a new matrix. Make it a 1 by 1, put a 0 in there, and then make it a 3 rows, 1 column, because we want something like that. -1, 6, -1. Okay. And then you're going to quit. Then you're going to do second matrix. You're going to press A. Then you're going to hit the inverse button where the matrix one. So you're not going to press second this time. So you make it inverse. Second matrix, and then you're going to hit the down arrow key to go to B. And there's our answer. So the answer is 3, 2, 4. And that's how you do it. You can do this for a 2 by 2, but if I ask you to do this one, you have to be able to do it by hand. So be able to do it by hand, which means you would have to use this formula right here. You would have to use this formula to get the inverse and then multiply it using the multiplication rule. Okay. Are there any questions on that? And I guess technically this one. Now, if there is no inverse, like you take the inverse and it says error. So like number 2, if you try taking the inverse of number 2, 3, 3, 6, 30, let's see what happens. So second matrix, edit, 2 by 2, and it's going to be 3, 3, 6, 30. Okay, I know I skipped the 0 thing, but I just wanted to get it done. Second matrix, A, and then take the inverse. And oh no, this one does have an inverse. So I take it back. That one actually did have an inverse. But let me see if I can just make a quick matrix. That. So I was wrong. It actually did have an inverse. For a second, it looked like it didn't. So I know this matrix does not have an inverse. So if you were to multiply it, and you got this, like, I guess dimension mismatch. Sorry. It's been a long day, so let's do it now. And you get singular matrix, that means there is no inverse, right? So any questions on that? Want to make sure. All right. And so the final thing that we have to mention for today is Cramer's rule. So 3.7 Cramer's rule. Okay. So Cramer's rule is just a technique so that you can solve a matrix that's 2 by 2 in a slightly different way. So, given ax plus by, cx plus dy equal e and equal f. Okay. The determinant of a with respect to x is equal to, you replace the x column with the solution. So this becomes EF BD. A y is going to be you replace the y column with EF like that. And x is equal to, so your x coordinate is equal to the determinant of x, respect to x, over the determinant of A, and y is the determinant of y with the determinant of A, like that. Okay? Any questions on that? And so then you would just calculate those values and you'd be good to go. Okay. Any questions? I just want to make sure. I'm actually going to stop there. It's because it turns out I actually have to do something. But I think that's a good stopping point. I'll do an example in the next in class or in a different review if I have time. But Kramer's rule is like bottom of the barrel. Study everything else before you study Kramer's rule, because it's just a technique that you might want to use one time, but it's really, I promise you, I would not focus on studying on this just because it's not that important, honestly. So, any questions? I'm going to do chapter 7 and 8 in class, sets and cardinality, counting, and all the probability stuff. And then on Thursday, if I have time, maybe I can do another video. We'll see. I'm just not sure if I'll have time, but we'll definitely review during class time. So we'll have a review during class. And then on Monday, we're going to finish 8.4, and we can start reviewing maybe just like 7.1 and 7.2 at the end of class. So I think this is a good stopping point, and I'm going to stop the recording.